explain why number 6 leads into this. So if you read through this, it says to be fully simplified, there has to be no radical left in the denominator, which is kind of right where my arrow goes. If this works. It's like freezing up on me. And if you notice on this one right here, 4 and 15 we can't simplify. 15 and 17 we can't simplify. So you're left with this radical in the bottom, and that's our issue. So there's something called rationalizing the denominator. And rationalizing, that deals with the whole that it's a fraction. So rational deals with, it's called fractions, like rational numbers. And then the izing is just the action you're taking on the denominator. Okay, so to rationalize the denominator, you're literally just going to multiply the top and the bottom, the numerator and the denominator, by the radical in the bottom, and that's it. That's it. So you're just going to multiply, and I just simplified that, by the radical in the denominator. So if we were to look at, oops, I didn't mean to highlight that. If we were to look at number 6 real quick while we had all this information in front of us, to rationalize this, we're just going to only multiply by the square root of 7, because that's what our direction said. Only multiply by the radical in the denominator. Well, the radical in the denominator is the square root of 7. Okay, 4 and 7 will never get multiplied. This is the outside, that's the inside, but the 15 and the 7 will. So 15 times 7 is 105. So we have 4 square root of 105. Okay, and then we'd have 15 square root of 49. And that's because of the 7 and 7. Well, we know the square root of 49 is 7. So we really have 15 times 7 on the bottom, which we already know is 105. So the question comes, can we simplify this and can we simplify the radical? Well, 4 and 105 have nothing in common, so that won't simplify. And we're going to look at 105 and see if we can take this any farther. So 105 divided by 5 is 21, and this should make sense of why we get these results. And 3 and 7. So prime numbers, nothing to group with, that's our answer. All right, so that's rationalizing the denominator. Okay. I'm only going to do a few of these examples. I don't think we need every single one. So I'll probably do like 4 or 5, and if you have any questions, just get a hold of me. So radical in the bottom, not allowed. Okay, so we're going to do the same thing on the last problem. We're going to multiply the top and bottom by the square root of 7. 4 is like a coefficient, is at the outside, I call it, and this is the inside, so it can't go together. And then 7 times 7, the square root of 7 times the square root of 7 is 49, and we know that's 7, remember? Square root of 7 times the square root of 7, when it's the same square root multiplied together, it's just that inside number. So we have 7, and that's the answer. It doesn't simplify. Okay. I'm going to go to 9 because it's kind of like 8, but with an extra step. So we're going to take this and separate it. Square root of 81, square root of 2. Because as that radical on the bottom, we're going to multiply the top and bottom by the square root of 2. And 81 times 2 is 162. And the square root of 2 times the square root of 2 is just 2. Now we can't simplify this because it's not in a radical, so we're going to ask ourselves, can we simplify 162? Well, it's even, so we can divide by 2, which is 81, and 81 is a perfect square, but we're going to keep on going. We can divide that by 3, and you get 27, divide that by 3, and you get 9, and divide that by 3, and you get 3. So 2 pairs of 3s, so 3 times 3 is 9, so that's what we get out of that. So moving down here, we get 9 square root of 2 over 2, and that's the answer. Although this looks done, it's not simplified. The radical isn't simplified all the way, so you have to go to this step. Okay. So let's do 11 and 12. I think that would really be good problems, and I think that's all you really need because they're pretty similar problems. So once again, we're going to multiply the top and bottom by the square root of 10, and you get 5 square root of 120 over 10. Square root of 10 times the square root of 10 is just 10. Now, we do have this 5 and 10 that will simplify, which get us 1/2. But we have to once again say, can we simplify the radical of 120? So we know 120 is divisible by 2, which gets us 60. We can keep going by 2 until we don't get an even number, which is 15. So then we have 3 and 5. So our only pair is this 2. So you're left with 2 times 3 times 5. If you put that all together, it's 30. So we have 2 square root of 30 over 2, and actually the 2's cancel, so this whole thing is just the square root of 30, and you're done. Okay, now 10 is like 12, so I kind of want to talk about this. Some people in the situation multiplied by the entire denominator, and although you can do that, that is perfectly fine. What happens is you do more work. So I don't know about you, but I'm a little lazy at times, so I like to do as little work as possible. So I'm only going to multiply by the radical. That's what the directions say. So worrying about the top, 2 sits by itself, and you can multiply the 3 and 6, and you get 18. On the bottom of the 3 sits, but square root of 6 times the square root of 6 is just 6, so it's going to multiply the 3 by 6. Now 3 times 6 is 18, but I'm going to go ahead and just simplify this 2 and 6 because they're both divisible by 2, so that gets you that 3. So the next thing I'm going to do is take care of the square root of 18, divide that by 2 and you get 9, divide that by 3 and you get 3, so that's that pair. So on the top you get 3 square root of 2, and on the bottom we have 3 times 3, which is 9. And we're almost done, but we still have these 3 and 9 to simplify, and we should know that that's 1/3. So you can either write it as 1 times the square root of 2 over 3 or square root of 2 over 3. All right, that's your notes for dividing. Hope that makes sense. Keep up the great work.